Well, hi everyone. We are working on practice test 9. Alright, now the first two problems, they're dividing a polynomial by a monomial. And when I'm working with that, I'm going to put each one of these over two xy. And just simplify each part. So 8 divided by 2 is 4. X cubed over x is x squared. Y squared over y is y. Minus 12 divided by 2 is 6. X to the 5th over x is x to the 4th. Y over y cancels. 18 divided by 2 is 9. X squared over x is x. Y cubed over y is y squared. You just subtract exponents. Alright, and 12x squared y to the 4th plus 9x cubed y to the 5th. I'm going to put this over 3xy cubed. I must just start rewriting the whole problem over. And y to the 6th over 3xy to the 3rd. 12 over 3 is 4. X squared over x is x. Y to the 4th over y to the 3rd is y to the 1st. 9 divided by 3 is 3. X to the 3rd over x is x squared. Y to the 5th over y to the 3rd, that's y to the 2nd. 15 divided by 3 is 5. X to the 3rd over x is x to the 2nd. Y to the 6th over y to the 3rd is y to the 3rd. Okay. That's division, but just by a monomial. Now we're dividing by polynomials, and we have long division, and then you'll see later we're going to use synthetic division as well. So, long division, I'll put my divisor as x plus 3. I'll put it on the outside. I got 3x squared plus 8x minus 7. And you remember to divide, multiply, subtract, bring down. My first division, just the lead terms, 3x squared over x is 3x. I'm going to put that right there. And then I'm going to multiply by distributive property. 3x times x is 3x squared. 3x times 3 is positive 9x. And then I'm going to subtract. This is one where we have to really be careful. 3x squared minus 3x squared cancels. 8x minus 9x is negative 1x. And then I bring down. I've subtracted and I bring down minus 7. And then I'm going to divide. Go through these steps again. Negative x by x, that's negative 1. So I'll put a negative 1 here, or minus 1. Negative 1 times x is negative x. Negative 1 times 3 is negative 3. And I'm going to subtract. Negative x minus negative x cancels. Negative 7 minus negative 3. That's negative 7 plus 3, which is negative 4. So there's my remainder. My final answer, I'm going to write 3x minus 1. Since it's negative, I'll just put a minus here. And I'll put 4 over x plus 3. Alright, next, I'm going to use long division to do this one. I'm going to take 3x plus 1, and go 3x to the 4th, minus 5x to the 3rd, plus x squared, plus 7x minus 2, 3x to the 4th over 3x, is x to the 3rd. So I'm going to put x to the 3rd up here. Now I'm going to distribute. 3x times x to the 3rd is 3x to the 4th. 1 times x to the 3rd is positive x to the 3rd. I'm going to subtract. 3x to the 4th minus 3x to the 4th is 0. Negative 5x to the 3rd minus 1x to the 3rd is negative 6x to the 3rd. I'm going to bring down, and I'm going to take negative 6x to the third divided by 3x, and that's negative 2x squared. So I'm going to add 2x. No, I'm not going to add. I am going to subtract 2x squared. That's negative 6x cubed. 1 times negative 2x squared is negative 2x squared. I will subtract, and 1 minus negative 2 is 1 plus 2, so that's 3x squared. I'm going to bring down plus 7x. I'm going to divide 3x squared divided by 3x. Let's see. 3's cancel. That's just x. So let's go plus x here. And that gives me 3x squared here, plus x here, where I will subtract. 7x minus 1x is 6x. Bring this down, that's minus 2. So 3x, 6x, I'm dividing again, divided by 3x is 2x. It is not, it's just 2. Concentration's starting to wane here, so I've got to focus. 2 times 3x is 6x. 2 times 1 is positive 2. You might think that that cancels. It doesn't. Those don't cancel. 6x minus 6x, that does cancel. Negative 2 minus 2 is negative 4. So final answer, that's my remainder, is x to the third minus 2x squared plus x plus 2 minus 4 over 3x plus 1. Okay, I think the long part is over here because we get to use synthetic division for the next two problems. If you remember, the divisor is y plus 3. The root for y plus 3 is negative 3. So always change that sign. Change that sign right there. And then write the coefficients. 3y to the third, negative 5y to the second, 3y, and negative 4. Go down a space. Bring down the 3, multiply. Negative 3 times 3 is negative 9. Negative 5 and negative 9 make negative 14. Negative 3 times negative 14 is 42. We add in the columns, that's 45. This is negative 135 when you add, and I'm getting negative 139 here. My answer, now 3y to the third divided by y is 3y to the second, and that's what this is here. 3y to the second minus 14y plus 45 minus, and then the remainder is 139 over y plus 3. Now number 6, I'm going to put 2 in the box. The root for y minus 2 is positive 2. That's what we put in the box. 1y to the fourth, negative 5y to the third, 0y to the second, there to trick you, 10y, and 6. Don't let it though. Bring down the 1. 2 times 1 is 2. Negative 5 and 2 is negative 3. 2 times negative 3 is negative 6. 0 and negative 6 make negative 6. 2 times negative 6 is negative 12. That's negative 2. 2 times negative 2 is negative 4. Got a remainder of 2 there. Y to the fourth divided by y is y to the third. And that's what goes here. 1y to the third minus 3y squared minus 6y minus 2. This is positive 2 remainder, so plus 2 over y minus 2. All right, number 7. This is the most recent thing we've done here. f of x is x to the third plus 4x squared minus x minus 2. F of negative 3, we plug in. And we go negative 3 to the third plus 4 times negative 3 squared minus negative 3 minus 2. So I'm going to take negative 27. This is 9. 4 times 9 is 36. Minus and negative is plus 3 minus 2. Negative 27 and 36 is 9. 9 plus 3 is 12. 12 minus 2 is 10. Okay. Negative f of 3z. So z is going to kind of be in the answer here, I have a feeling. I'll put a negative here. And then I'm going to put 3z to the third plus 4 times 3z squared minus 3z minus 2. I replaced all the x's up here with 3z because we're finding f of 3z. I also have this negative out here I need to think about. Okay, now I'm going to just try to do these parts here. 3 cubed is 27 z cubed. So this is 27 z cubed plus 4, 3 squared, that's 9, times 9 z squared minus 3z minus 2. I need to take my next step here. Four times 9 is 36. So that's 36z squared minus 3z minus 2. And then distribute this negative. So that's negative 27z to the third minus 36z to the second plus 3z plus 2. Okay. I'm going to put plus 2 here because that's actually on the other page. Okay. What is the degree of f of x? The degree is the highest power of x. The degree is 3. What is the lead coefficient? It is the coefficient of the first term, x to the third, when they're written in order. The lead coefficient is positive 1. Okay, now number 8. We're going to use this graph to describe the end behavior. As x goes to negative infinity, so as we go left, we are going down. F of x is meaning down, going to negative infinity. As x goes to positive infinity, that goes up. I would write positive infinity there. Does this function represent an odd degree or an even degree? The fact that one end is down and one end is up is odd. And it's an odd degree function. Could be like a cubic function to the third power. How many real zeros? Well, you just count the number of x-intercepts. 1, 2, 3. That's how many real zeros this thing has. Now number 9, let's describe the end behavior. On the left end, negative, x is negative, that's the left end, it's up. So that's positive infinity. And on the right end, it's also up. That's positive infinity. Does this function represent an odd or an even degree? When both ends are either up or both ends are down, that is an even degree. Number of real zeros, I count 1, 2, 3, 4. The number of x-intercepts, or the number of roots, or the number of zeros, they all mean the same thing. 1, 2, 3, 4. There are 4 real zeros there. Number 10. Describe the end behavior. The left side is up. So I'll go positive infinity, and the right side, as x approaches infinity, is down. So I'll go negative infinity. Does this function represent an odd degree or an even degree function? And I would say that we are looking at one end is up, the other end is down. That's an odd degree function. Number of real zeros. I count 1 here, 2 here. There are 2 real zeros here. Uh-oh, lost focus here. Number 11, the end behavior. As x approaches negative infinity. So as x goes way left, this is going way down. As x approaches positive infinity. On the right side, it's going way down. Okay, does this function represent an odd degree or an even degree function? The answer is this one's an even because both sides are doing the same thing. Both sides are down. How many real zeros are we seeing? I'm seeing 1 here, 1 here, and 1 here. I'm seeing 3 real zeros. All right, there you go, everybody. Take care. God bless.